So, good evening everyone. So, the course name is CMOS design and the course code is 50EC505. The CMOS design comes under the module name VLSI. Myself D. Mugilan, Assistant Professor, KS Rangasamy College of Technology. So, today we are going to see about the how we will do a simple CMOS inverter experiment using Tanner software. So, the layout design, we are going to see about the layout design. So, for the layout design we are using Tanner EDA. The Tanner EDA, the S editor. So, if you see the S editor, this S editor means schematic editor. If you double click the schematic editor, S editor, so once the S editor opens, go to file, the top left corner, file. In the file you will select new design. After selecting new design, you will having a pop-up window, design name and a create in folder. Design name you will give inverter and the open in folder the prior selected folder, then click OK. After that you will ask add library. In the add library, then click the three dots in the add library and give OK. It will move to the documents. After selecting the document, it shows the file name MISC, that is MISC. In the document library you will have a generic 250 nanometer devices. Select the generic 250 nanometer devices. After selecting the generic, then you will add a MISC, then open view. In the open view, the cell name is cell 0 and the view type is schematic and the interface name keep as it is, then select OK. After select OK, you will have a schematic editor view, and the schematic editor view, in the left side you will have two things. Then one is library, next one is the library and in detail view. In the library you will have you added generic 250 nanometer devices, then MISC. Then you click the generic 250 nanometer devices. In the generic 250 nanometer devices, in the generic nanometer devices you will have the PMOS, NMOS, 2.5 volt. So in the generic 250 nanometer device you select the nanometer, the NMOS device, 2.5 volt NMOS device. After selecting the 2MOS NMOS device, after selecting the NMOS device, we will place in the schematic grid view. The black page in this view is known as the grid view. Once you click on the device, in the left side the properties of device is showing. The properties are the length is 0.25 micrometer and the width is 1, and the model, order, parameter, the pin order, prefix, all the properties of the NMOS devices shown in the right side view. So next repeat the same procedure to place PMOS devices. Once you drag and drop the PMOS transistor, then you will add the PMOS transistor also, the same procedure. So after adding the PMOS transistor, then you need to add VCC. So the VCC, then you can pick the VCC from the MISC shown in the library. Once you added the VCC, next you add the ground. So the ground also you can search in the MISC and add the ground. Then once you drag and drop your VCC and ground, then connect all these devices by using wire. The wire is placed in the tools, that is select wire. So after selecting wire, connect the VCC to the source of PMOS and ground to the drain of NMOS. Then connect the both transistors, PMOS and NMOS transistors gate. So after connecting all these wires, so forcing the input and output port. So the input and output port, that is A and B, you will invert the port A and input port A and output port B. So after completing all these connections, go to the tools bar. In the toolbar, click here to open the netlist in the T-Spice, and is shown in this T-Spice like this icon. After clicking open that T-Spice icon, you will have that T-Spice program. In the T-Spice program, place the cursor here to include the library. So the library, so go to the documents library, you add the generic 250 nanometer library. After adding this library, so the insert command is placed. So after insert command, go to the transient in the spice command wizard. In the transient, you will have a maximum time 100 nanometer. The simulation is 100 n. The output start time is 0 n. You have to give the minimum time simulation and the output start time here. So place the next step is to place cursor here to insert transient analysis. So next voltage sources, the voltage sources and the constant. Voltage source name is V1 and the positive terminal is VDD and the negative terminal is ground, and the DC voltage value is 2.5 volt, and then press insert command. Next the voltage source bit analysis. So here you will have bit source is V2 and the positive A, negative ground, and the bit values is 0, 0, 1, 1, 0, 1, 0, 1, 0, 1. Will feed the force voltage, and the on value is 2.5 voltage. Then you will give insert voltage, insert command. After inserting command, next go to the transient analysis. In the transient analysis, the node name is B and the voltage and the VB ground, and type the port name and you want to view the output. Then click add, then insert command. After that, after feeding these data, go click here to simulate. You will have an icon, just click here to simulate. So the click here to simulate, then click here to open waveform viewer. So the icon is waveform viewer. After the waveform viewer, you will have the output of the inverter. So if you give 0, you will have 1 as output. You will have 1, you will get 0 as your output. So if you use this separate plots of waves, you can view separate input and output waveforms. So this is a separate waveform of the inverter by using the tanner.